All right, projectile motion. Airplane and crate. This is a problem out of the textbook. Here we go. This is a multi-step problem. We got a plane traveling horizontally, so let's draw this. We'll draw the ground first. Okay, there's the ground. Let's make that a different color. Black on black is not good. There we go. And we have a plane going in this direction horizontally. And we'll have plane. Okay. And it's cruising along in this direction here. Then it drops a care package, a supply crate, whatever, and it falls down, just kind of like this, and hits at that point. It's traveling at 100 meters per second. 100 meters per second. It is 50 feet off the ground, or 50 feet, 50 meters off the ground. 50 meters. Make that a little bit neater. And it wants to know, and that's it. That's all the information you're given. You're not given time or anything else. It wants to know, first, what horizontal distance does the drop package travel before striking the ground? So it wants to know this delta x right there. That is your goal. Delta x. And to find that, you would be golden if we knew the time. But we don't know the time yet, but we can figure this out. If you ever know how far something falls, you can figure the time based on this formula right here. Delta y equals 1/2 gt squared. Very popular formula. So this would be negative 50 meters. I'm going to leave the units off to keep this as clean as I can get here. Negative 9.81 meters per second squared times t squared. And that would turn into the following. So we would have 50 equals 4.905 negative. That's 1/2 times 9.81 t squared. And we'll divide by this coefficient here, 4.905. So 50 divided by this is about 10.19, and that equals t squared. So then we square root both sides to solve for our t, and that is 3.19. 3.19 seconds for the time it takes. So it takes 3.19 seconds to fall. Whether it's falling straight down or sideways, we know by now that that does not matter. It takes 3.19 seconds to hit this target out here. But how does one find this distance? Well, that's based off of velocity equals delta x over t. And we're talking sideways velocity. Well, we know the sideways velocity. This is our v sub x here. This is our v sub x. That's the velocity sideways. The plane's velocity is the same as the crate velocity. So that's how that's going to work. So 100 meters per second equals delta x over our time interval, which is 3.19 seconds. And to solve for delta x, you're going to multiply. So it's 3.19 times 100, and delta x would equal 319 meters. So to find out how far this thing went, it would simply be 319 meters. So that's the first part of that, so that gets a circle around it. There we go. Now, that's the first part. So that satisfies this part here. Now, this part, what is the velocity of the package upon striking the ground? Well, we know, let me draw another triangle. Let me just set this up again. So we get the plane here, straight down, over, and then that's the package drop path. So we got a plane here. There it is. And it's cruising this way. But now we're going to look at this as if it's a right triangle, which it kind of is. the velocity, horizontal velocity on this triangle, because this is where the supply crate hits the ground. This, if we look at this in terms of velocity, this would be 100 meters per second this way. Now, how fast does it fall vertically? So what is this fall speed? Well, we have to use another equation for that. Let's do it in purple. So to find this velocity here, that would be v equals gt, gravity times time. So if we know a time interval, we'll be able to figure out its falling speed going down, its component vector pointing down. And that's 9.81 times the time, which is 3.19. All right, and that is 31.29, so I'm just going to call it 31.3 meters per second. So that would be this, 31.3 meters per second. Think about it, people. This crate gets dropped as this plane is going 100 meters per second this way. Okay, it's zooming off in this direction, and it starts falling. It falls. Its fall speed is actually slower than its speed going this way. So this triangle is a little out of whack. It would actually be a little bit flatter, kind of like this, kind of like that shape. That's what happens when I freehand triangles. But the thing you're looking for, what is the velocity of the package upon striking the ground? That's the hypotenuse here in terms of speed. So what we need to do is Pythagorean theorem, a squared plus b squared equals c squared. And when you do that, I trust you can do that. It turns into 104.8, and let me double check that. 104.8 meters per second. Now, since this is a velocity, remember, that's just Pythagorean theorem to get that. So I'll put a circle around that. That's part of it. We need to know, since it's velocity, we need to know a magnitude and a direction. Well, this is the magnitude. The direction would be maybe this angle right here. So we need to figure out what that angle is. And that would be maybe tangent of this angle theta here would be this side over this side, opposite over adjacent. So that'd be 31.3 over 100. And when you do that, you should get something like 17.4 degrees. 17.4 degrees. All right. Kind of a complex little problem. It looked harmless to start off with. It is definitely what's called a horizontal projectile. This is the same as the cat chasing the mouse and sliding off the table the other day. So it's the same kind of problem. I will talk to you later.